This video will cover Notes 10C Part 2, which is the quadratic formula. For 10C Part 1, we talked about simplifying radicals with the Pythagorean theorem. Another type of theorem or formula that we will use the simplifying radicals with is the quadratic formula. So we learned the quadratic formula a couple of units back, and so we're going to look at it again and talk about, now that we know how to simplify radicals, how to do that with the quadratic formula. So just a reminder, here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So obviously, since we've got that square root right there, sometimes when you get the square root, you're going to get a perfect square, which you can simplify, and that's great. Sometimes you get something that's not a perfect square. Now in the last unit, I just had you leave it, but now that we know how to simplify radicals, we cannot leave it anymore. We have to simplify it if it's not a perfect square. All right, so let's try example 1. Now remember, we have these a, b, and c's. So remember, a quadratic looks like this in standard form. Y equals ax squared plus bx plus c. So before you use the quadratic formula, you have to get your equation in that form. So now I'm going to identify in example 1 your a, b, and your c. Example 1 is already in standard form. Another thing that you want to have when you solve a quadratic is you have to equal 0. Okay, you're solving for when y is 0. Okay, so a here is 2, b is 8, and c is negative 17. Make sure you pay attention to the sign in front of the numbers. All right, so now when we use the quadratic formula, we have x equals negative b would be negative 8 plus or minus the square root of 8 squared minus 4 times a times c, all divided by 2a. Okay, so that's what I would want to see first. Now, this is going to be non-calculator, so you need to be good with your multiplication skills in order to reduce this. So let's just simplify following our PEMDAS. So we can go ahead and in the denominator, that's 2 times 2 is 4. Now inside the square root, again, we need to follow PEMDAS. So 8 squared is 64. Now, here's where you get a little bit harder because you've got 4 times 2 is 8 and then 8 times 17. I don't know 8 times 17 off the top of my head, so I'm going to go ahead and do that off to the side. If you need to do that, go for it. So try not to use a calculator here. So 7 times 8 is 56. 8 times 1 is 8, plus 5 is 13. So 17 times 8 is 136. Also notice, and don't forget, you have this negative 4 times this negative 17. So when those multiply, you're going to end up with a plus 136. Okay, so that's what I would do for the second step. Now I would go ahead and add what's inside my radical. So 64 plus 136. Again, if you need to do that off to the side, do it off to the side. So that's going to be 200. Okay, so we have the square root of 200 and then divided by 4. Now, like I said in the last unit, we would stop there. However, 200, we now know how to simplify. It's not a perfect square, but we need to look for the perfect square that's inside 200. Hopefully this one's pretty obvious. It's 100 times 2. And then the square root of 100 is 10. So the 10 comes out of the radical. The 2 stays inside the radical. All right, so then that's what my answer looks like. However, if you look, you have this negative 8, this 10. Now the 2 does not count because it's inside a radical, so just ignore that. And then the 4. All of those can reduce by a factor of 2. So if each of those numbers all have something in common, you need to divide by that number. Again, do not care about what's under the radical. So since all of these can divide by 2, 8 divided by 2 is 4. Plus or minus 10 divided by 2 is 5, root 2 stays the same, and then 4 divided by 2 is 2. So this is my final answer. Okay, so if you had left the answer here, I would take off points because it's not completely simplified. Okay, so that's how we use the quadratic formula with simplifying radicals. So we're going to try 2 more examples. Okay, example 2. Notice example 2 is not in standard form. We have x squared plus 1 equals 3x. So what I want to do is subtract that 3x term on both sides. First of all, because I want to equal 0, and also I want to have ax squared plus bx plus c. All right, so now to write this, I'm going to put my x squared term first, then the minus 3x next, then plus 1, and now I'm in standard form. Okay, so quadratic formula, we want to identify what a, b, and c are. So a for this one is 1. Again, don't say x squared, it's the number in front of x squared. We don't see a number, so that number is 1. B is negative 3, and c is also 1. So now for the quadratic formula, we have x equals negative b, so that's negative of negative 3, so that will end up being a positive, plus or minus the square root of b, negative 3 squared, minus 4 times a of 1 times c is 1, all divided by 2 times a. All right, I'm going to simplify this. So this will equal the negative of negative 3 is a positive 3, plus or minus negative 3 squared. Be careful here. Again, I put parentheses around that negative 3 because the negative is also being squared. So when you square a number, you always will get a positive number. So that b squared, it doesn't matter whether b is positive or negative, you're always going to get a positive number when you square it. All right, and then minus 4 times 1 is just minus 4, all divided by 2. This one's pretty easy because when I simplify, 9 minus 4 is 5. 5 is simplified. There is no perfect square inside of 5, so we actually don't have to do more steps like we did in example 1. 3 and 2, neither of those have anything in common, so this one is actually pretty easy. We're done. Okay? All right, last example, example 3. Now this one's a little bit different because we don't have, remember, ax squared plus bx plus c. We are equal to 0 here, but we're missing that bx term. Okay, so I'm going to show you what to do with the quadratic formula if you're missing the bx term. So if you're missing that b, what that means is b is actually 0. So what I can do is I can kind of fill in that b term. So you can kind of think of that b term as like a ghost or something. You can't see it, but it's there, but b is 0. That's why there you don't see an x, okay? But you do have to know what b equals. So if you don't see any b at all, b is going to be 0, okay? All right, so now our a is 1, our b we said is 0, and our c is negative 12. So now we're going to solve using the quadratic formula. So we have x equals negative b, and b is just 0, so I'm just going to put 0, plus or minus the square root of 0 squared, which again would just be 0, minus 4 times a times c, all divided by 2a. All right, now when I simplify this, if you have 0 plus or minus, you still need the plus or minus part in front of the radical. So we have plus or minus. Now, the reason I wrote the 0 squared part is because it's going to be 0 minus 4 times 1 times negative 12. So that minus is still very important there. And actually, I don't have to write the 0 here. Okay, so then the negative 4 times 1 times negative 12 will end up being positive 48 divided by 2. Now remember, you cannot just divide this 48 by 2 because the 2 is not inside a radical and the 48 is. But you do have to simplify because square root of 48, it's not perfect, but it does have a perfect square in it. Now 48 is one of those that a lot of people think of 4 and 12. 4 is a perfect square, but it's not the biggest perfect square that goes into 48. It's actually 16. So hopefully you can remember that with 48, because 48 is a pretty common one that we see. So 48 is 16 times 3. All right, now if you had thought, I'm just going to do this off to the side, if you had thought of 4 times 12, you didn't remember 16, you could definitely have done that. So then you get 2 root 12, and then 2 root 12, 12 you just have to recognize still has a perfect square of 4 in it. Okay, so then you would have 2 times 2 root 3. Okay, so you could have done it that way, but it's a little bit longer. You have 2 steps rather than the 1 step. Okay, and then just like I just did in green, that square root of 16 will become 4 root 3 divided by 2. All right, and now you can simplify because the 4, which is outside the radical, and the 2 can divide. 4 divided by 2 is 2, so this will end up being plus or minus still 2 square root of 3. So we have the 2 answers. We have the positive 2 root 3 and the negative 2 root 3. All right, so that is quadratic formula with simplifying radicals.